Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
When I was given information to read about Matt Genovese, founder and CEO of Planorama Design and our guest on the Software People Stories podcast, one thing caught my attention: getting it right the first time, and how he brought in some of the principles of hardware design into software engineering. When we started the conversation, it began for Matt at a very young age, tinkering with electronic kits, impactful dinner time conversations with his engineer father, and programming since he was in middle school. Our conversation extends over two parts, where the first one explores his experience working at Motorola to how he realized that focusing on getting requirements right meant building better software. Stay tuned for this conversation. We explored a lot of topics here. I'm sure you'll find something interesting if you have had to produce or consume software at some point in time. Good morning, Matt, and a very warm welcome to you to the Software People Stories podcast. I'm very excitedly looking towards this conversation.
Thank you very much. It's a pleasure to be here, and I'm looking forward to it as well.
We usually started the podcast by asking our guests to introduce themselves. So how would you like to do that for our listeners today?
Well, so my name is Matt Genovese. I've been an engineer professionally for about 25 years, but realistically, I started longer than that. When I was a kid, going back to when I was 8 years old, I started on the Commodore VIC-20 back in the 80s, which will probably date me a bit. But I started learning how to program as a kid and on the little 8-bit computers. And my father was an engineer, so he was very enthusiastic to have me start learning how to use it, how to program, and I was building things on it and trying to even build, I guess, what you would call IoT back when I was in middle school. Trying to build projects that might use the Commodore, but anyway, fast forwarding from there, I've been about half my career I worked in chip design. In logic design and verification. And then the other half of my career I spent in product software, on the software side of the world, in product management, various roles in that area. And then today I run a software product requirements firm called Planorama Design. We do product requirements for software and IoT systems. And that goes everywhere from the requirements and discovery all the way through UX design and documentation. So in a nutshell, that's a very fast forwarded look at my life going back from 8 years old forward.
Thank you. I'm sure we'll explore bits and pieces of that, through the course of this conversation. Mm-hmm. So you said you got interested in building things and making things ever since you were little, and perhaps having a computer on hand and having a parent that's an engineer too.
Yes.
Helped. Did it help, or and this is a question I have for a lot of people, because where we grow up in this part of the world, your parents definitely have a say in the kind of education you choose to pursue, as well as what you do. And
Sure.
for example, my dad is an engineer too, but I would refrain from asking him questions, because then he would ask me 10 questions in return, and then I'd get upset if I couldn't answer them.
I'll tell you this, my father and I grew up with my mom and my dad, but my dad being the engineer, we ended up getting into very interesting conversations at the dinner table, where we would chat about like trigonometry. He taught me trigonometry when I was in middle school or earlier, because we started talking about triangles and how they were interesting and the different properties of them. We would talk about things like infinity, right? And what does that mean? And I started realizing that triangles were interesting because if you start taking the one point of the triangle and drawing it out very, very far, those angles on the other two sides start going to 90 degrees. And I realized, like, wait a minute, does that mean that lines that are 90 degrees, that, on a triangle, does that mean when the point goes to infinity that those angles are 90? And does that mean parallel lines meet at infinity? And he was like, well, I'm not sure. I better take that to work and start talking to the other engineers and figure that out.
Wow.
And but it was more conversational, and he certainly, that was an area where he had a lot of interest. He was a mechanical engineer, and I had an appreciation, and I certainly did like to tinker and take things apart, which was sometimes my downfall, because I had to get them back together and hopefully put them together in a way that it still functioned. But while mechanical was his area, my area was more on the electronic side, and they had given me, my parents gave me one of those 50-in-1 or 101 electronic kits from Radio Shack, and I used to put together different projects on that, and I really enjoyed it. But he certainly did play a part, and he wasn't that knowledgeable in the computer area, and that's where I ended up really just diving headfirst in and became a bit of an expert in that area at a young age, at least in the sphere that I was in. And that wasn't his area, but the drive to understand, the drive to know, hey, I want to see what happens beyond that curtain. I don't like black boxes. I don't like just trusting that something, works because I say it does. I want to know why.
Yeah.
That drive to understand why, really, I think is what, it's that curiosity that really drew me into engineering, and yeah, I think that's a long way around the barn to say that it was my dad certainly had an effect on me.
Yeah, that's interesting because I think it's also a way of finding a connect with your kids. And I remember times my dad was an electrical engineer and worked in a company that built transformers and DC generators and motors. So he'd take us on these trips to hydroelectric power dams and actually showed us how power was generated.
Oh, wow.
And then that became very interesting because part of my course in engineering was to study, turbines. We had it as a subject, one of the subjects. And I was like, hey, I've seen this. I've actually seen, water falling from a waterfall and a dam there and the force of the water actually spinning those turbines and generating power. And then I remember when I came to my second year of college, I had a subject on electrical machines. And, there was these tough problems that we'd been given to find out the how much of winding you need to put on a transformer.
Oh, that's right.
Okay.
That's
step up, step down, and
Ratio.
all of that. And then he said, why don't you just come with me to the factory one day and I'll actually take you to show you how it's done. And I think that for me was like transformational moments to say that I can appreciate what the professors in college are trying to teach us when you actually see, how it's being built and made. Yeah. So what did you do after that, Matt? Yeah. Sorry, go ahead.
Well, no, I was actually going to mention, and I think that's a challenge that we have today with the future generations. That there was so much that was accessible to us when we were kids.
Yes.
Now, granted, not every child could go walk into a hydroelectric plant, but at least in terms of electronics and computers, while they were very nascent, certainly the PC industry was just starting to grow. You could take it apart. You could see it. You could figure it out. You could try things. I mean, that's how Steve Wozniak was able to go build. He had discrete components. He could put it all together and built the Apple I. And nowadays, that's not really the case. We are at a point where it's not made to open. In fact, that you'll void the warranty and you'll break something because it was made to, for privacy concerns. And I understand the reasoning for that, but boy, it really does inhibit, I think, the tinkering that was allowed to us as kids, that now you just, if anybody's like me, if it was a version of me who's now 8 years old, I don't know where I would find those things in order to spur on that curiosity, at least be able to satisfy it, right? To get to a point where I could look at something inside.
Absolutely. And I think this is an interesting point right here, because learning design is something that interests me. And I always felt that having a combination of involving all your senses when you learn something, or you're driven through with curiosity, and then you'll end up learning something. Learning is an outcome. When it involves all your senses, or when you're engaging all your senses, it's so different. And
that's right.
I hear you when you say that today's generation is somewhat limited. And yes, given the fact that they really can't take things apart, today, sometimes I feel that when there were mechanical drives that were rotating inside a laptop, you kind of knew that the thing was working.
That's
versus,
right.
versus
you can put your
solid-state
ear
drives.
to it. You can hear like, oh, it's not even on. It's not even spun up yet. That's right.
So
I remember that.
Yeah. So Matt, what did you do after that? I mean, where did you go study? And
so I went to I grew up on a farm in upstate New York, in a small town called Owego, New York, which is right on the banks of the Susquehanna River. Big farm country, it's a small town. I grew up surrounded by cows and chickens and corn and nature, and I loved that. But it also gave me time. It was like, well, there were no kids. There was only one friend that happened to be down the road, but really I was kind of isolated. So I ended up picking up the computer, and so I moved forward with that. And I kind of knew what I wanted to do. I knew I wanted to work in computers in some way, shape, or form. I went to a school called RIT up in Rochester, New York. I got my bachelor's in computer engineering, and had a wonderful professor, and he was the head of the department, named Roy Janikowski. And he was a fantastic professor. I understood him in a way that he gave me a real love for computer engineering, love for the formality of it, but he's also a well-rounded person. He was a pianist and loved music, and so I really looked up to him. I came down to Austin, Texas after graduation, moved down there, and I worked for a company that you may have heard of called Motorola, and I was there for about 12 years. So I worked in the back end, basically everything from the fabrication out. I was responsible for a product from getting it to production, and then I spent the other, say, 2/3 of my time there moving into design, which is where I really wanted to be eventually. And I moved into functional design and verification of processors and SoCs, but mainly on system on a chip, on PowerPC based processors, RISC processors, which is funny because that pendulum has really swung back, hasn't it? It used to be, that PowerPC was, it was in the Mac at the time. IBM and Motorola had their partnership and built that. And then it kind of went to the wayside. It became something that was, then used in automotive and networking chips. But boy, it really came back into the limelight with Apple's introduction and just showing how that architecture really presents a lot of benefits, from a power performance and area standpoint. And so I've been excited to see how that has played out. And but yeah, that was where I spent, at Motorola, which became Freescale Semiconductor. I worked in verification there, learning quite a bit about how you have to make sure that chip works when it gets out the door, right?
Yeah.
It's very different than software.
Yeah, and those were the spaces where you actually built to test. you verify first and then you code, right?
Well, you certainly, there is an emphasis on testing, and we call it verification, or I think Intel calls it validation. But regardless, it's pre-silicon. Make sure it works, and usually that's done on the design and in the Verilog or whatever the HDL code.
Yep.
It's done in a simulation, and it's done in what's called formal if you're using assertions. Regardless, there is a real emphasis, as you might imagine, verification, because you have to ensure that chip, that bugs are not escaping, at least killer bugs, especially, because you don't get to push out a bug fix. You don't get to, there's no update to send out. You've got to respin, metal layers or whatever it is, or my gosh, if it's a full mask change, it's millions of dollars that's just going to cost. And so I learned about the emphasis of and the thought process that goes into verifying that chips are going to function, and how you prioritize that, the different methodologies. And it's interesting how that tends to spill over into software, but in software it's handled a little bit differently. But I really appreciated that experience.
Yeah. No, I think people have tried hard to imbibe test-driven development into various software engineering methodologies, but that's kind of I think because there's so much freedom to write code, I think this kind of there have been companies that have successfully adopted it, but don't see too much of it still.
Yeah, I agree. Verification, there's so many things that can happen in a chip that the emphasis given to it in most companies is much more than QA is given in a software company. So in a hardware company, verification engineers typically outnumber designers meaning the chip designers, the logic designers, at least 2 to 1 from what I had seen. Now maybe that's changed, but at the time, verification, it was a well thought out methodology because again, you certainly couldn't. We had to get it right the first time as best as you could. And so you prioritize what you're going to be working on. You have different types of verification that occurs. You might do some directed testing, but you also employ some randomized testing. You may do system level testing in terms of taking the design and dropping it into an FPGA, into an emulation environment where you can try to boot Linux on it, right? And you're coming at it from so many different angles because the cost of releasing bugs is so enormous. And so I do believe that software, and including test-driven development and others, have benefited from the rigor that has gone into the verification activities for chips and hardware. Yep,
absolutely. What did you do after Motorola, and how did you go from the VLSI EDA space into user experience design and, as you called it, product requirements discovery?
In chip design or creation of semiconductors, creation of hardware, design is a required element. Right? It wouldn't make sense to release a chip without being designed, right? Design, you have it in every engineering discipline: mechanical, industrial, electrical, civil. There's always an element of requirements and planning that go along with design. But what's interesting though is that only when you move into software engineering in that realm, that the term design is kind of relegated to optional. It's relegated to making pretty screens, which is what UX design, just make it look better or make it easy to use. And then directors and managers wonder why projects go sideways or why budgets are blown. That's I think the challenge. Design has, it is what it is, has become in software again relegated to pretty screens, to UX design, when in reality design is all about requirements, and that means understanding and prioritizing what the needs are for the users, for the business, for the technical team, and mapping that out in a way that we can execute against with the information that we have now at that time. In software, we do have this benefit that we can iterate, and we use it. We use that in agile methodologies, in that type of arena where if we understand that we're going to learn during the process, if we're going to learn things in 6 months that we didn't know today, and that might affect how we build or design this product, then agile is the right way to go. But it also, sometimes I think agile has become synonymous with, well, we'll just, iterate, we'll try to get it right, but we're, not spending a lot of time on figuring out what the requirements need to be. That presents, I think, a challenge for everybody downstream, the people who are building it, which is, the designers, the actual, UX design, the developers, and the QA team. We need to make sure they have what they need to execute. So,
and you've articulated this in your article, and I'm quoting from there, saying that stakes are high, and as I've witnessed often, they have not received requirements needed to execute efficiently. We're talking about high-fidelity visual specifications and the business rules written in well-organized, thorough, dev-ready internal product documentations. When developers can develop and not have to design screens or wait for requirements, products simply get out of the door faster.
That's right.
Yeah,
that's right. That does sound like something I would say.
Yeah, this is from your blog on SemiWiki, and I was going through that, and this really struck me because there's very few people that I've seen who mention tackling time to market problem, by ensuring that developers have all that they need to code it right. And when you referenced iterations that were really going nowhere, one of the problems could be this, right? The requirements are simply not written right or interpreted in the right way. Or why do they have to be interpreted in the first place?
Well, that's right. And when I've spoken with developers, and by the way, we do this periodically. We at Planorama will take our user story format, the way that we write our documentation, and we will speak with developers in our network that we don't work with. They just happen to be people that we know that are colleagues, former colleagues, and we walk through our format and we get feedback from them to make it better, because at the end of the day, the developers typically don't want to figure out requirements. They want to code. They want to get the product or the feature done and out the door, because they are the last ones holding the baton. Typically, they kind of like I remember back to the days at Motorola when we had a chip that was going to be taped out. The last ones to hold the baton were the physical layout folks, and inevitably it was like Christmas when they would somehow always get the final designs, the final HDL, and they'd have to go and work over Christmas to get this done so it could be taped out and into the fab. And I always felt terrible for them, but they were the last ones holding the baton before it went out the door. There's a lot of pressure on them, and I think developers and QA have the same problem. Many don't empathize with them, but they sometimes are receiving bullet points, in a story and saying, "Hey, we need to go build this." And sometimes they become the designers too, or product managers, kind of take their swing at it. That we don't have the team filled out in a way that everybody downstream from requirements are receiving exactly what they need in the format they need to be successful. And again, then we wonder why projects go sideways. If we focus on getting those requirements delivered with all, not only the best case path, but the exception paths with all the screens that detail exactly what those paths look like in high fidelity, so there's no question about how it should work, you'd be surprised how fast and happy developers are to go and build it. They're very quick. And QA is the same way. QA, they have to develop test cases to evaluate that it was done correctly in the same way we did in verification. So what we do at Planorama is we actually write the not only the user stories, but we write the test case suite for every feature. So the QA team already has a leg up. They already are starting from not square one, but they're starting from like square 30, and they already have these test cases written that now they can go and implement and perhaps build upon. But we want to accelerate their efforts too to get the testing in place, because we see, and again, we think a little bit differently, but from our perspective, a bug is a UX issue. It doesn't matter if it's a feature. We kind of have that joke: is it a feature or is it a bug? The user doesn't care if it doesn't work the way they think it should.
Yeah,
it's going to impact. It's going to impact the product and how it's seen and received, and eventually affect sales. So we treat bugs as a UX issue that we try to prevent from a design standpoint.
Okay, that's interesting. And what is it that you've learned or you use in terms of writing effective stories? And when I say stories, I don't only mean user stories, but also the non-functional stories. For example, if there are non-functional requirements that you're looking at, like data ingestion or scalability or performance or response times or throughput.
Sure.
I've seen that a lot of engineers struggling with first the product managers struggling with articulating those requirements and the understanding of those, so that you really have a solid foundation or a backend that can support what is needed upfront. So if there's like 1 million users that's trying to that are constantly accessing the system, it has to be available. It has to retrieve, continuously ingest data, do some processing, give responses, especially today where people are probably looking for responses in near real time to take decisions, to decide, let's say, how can I, let's say, optimize my marketing spend? Where should I put in, if I am advertising here, will it give me a better ROI? Stuff like that.
Right.
So what have you done to sort of encourage people or write better stories?
Stay tuned for our next episode, featuring the continuation of this conversation with Matt Genovese, founder and CEO of Planorama Design, where we begin with writing good stories to deliver great software.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.